Good afternoon from Ann Arbor, Michigan, at the University of Michigan School of Information, and welcome from wherever you are in the world. My name is Amy Homkes-Hayes, and I'm the Assistant Director of Academic Program Development in the University of Michigan School of Information and a proud University of Michigan alumna. I am thrilled to be joined today by three faculty colleagues from the University of Michigan School of Information who are very eager to talk to all of you about our Master of Applied Data Science program. I'm going to go ahead now and let them introduce themselves. Elle, let's start with you.
Sure thing. Hi, I'm Elle O'Brien. So I'm a relatively new hire. I joined full-time in March. I'm super excited to be here. So my background is that I did a degree in math degrees. My graduate work is in neuroscience, speech perception. I spent a year working at an open source startup, working on tools for data scientists. And I really care about, standardizing data science education and making sure that data scientists really have their craft down. And so I'm, really excited to be part of the faculty at MadsDAO.
Thank you so much, Alan. We are so excited to have you here. And certainly your industry experience coupled with your academic experience demonstrates the strength that you're bringing to our program, giving students a lot of insights into real-world applications of the very things that they're studying in Mads courses. Next, I'm going to go ahead and let our esteemed program director and fantastic faculty, Qiaozhu Mei, introduce himself.
Thank you, Amy. Hi, everyone. This is Qiaozhu Mei. As Amy said, that I wear the hat of the faculty director of the Mads program, basically trying to serve the program, all the students and the staff, the instructors to build the best data science program in the world. When I put my hat of the director down, I am a computer scientist working on large-scale data mining, machine learning projects. And I apologize for my virtual background. That was not taken from Michigan. That was taken from Peking University in China, in Beijing. Sort of like this because the Chinese characters is that the Point Tree Research Institute. If you look at what I teach in Mads, I'm not just teaching hardcore, data science, data mining stuff. We use data mining to generate Shakespeare's sonnets, and we use emojis a lot in the courses. So check it out.
Thanks so much. And then finally, I have a panelist who likely needs no introduction at all, given his widespread international acclaim on platforms like Coursera, which hosts our degree. But that being said, I'm going to go ahead and let Chuck Severance introduce himself.
Thank you, Amy. I don't get to do these as often as I like. You do them more often, and I really enjoy them. So my name's Charles Severance. I've been a faculty member since 2007. Prior to that, I was a software developer and an IT person and made the transition to faculty. You may know me through Python for Everybody, which is the world's largest and most successful programming class ever. And often it is one of the ways that a lot of people learn to program and get interested in data science. It's kind of the gateway to data science. In my spare time, I write free and open source software for educational technology, like the Sakai project. I also developed the standard for educational technology that allows things to plug into Coursera called Learning Tools Interoperability. And that's how we deliver to you a wide range of much more exciting and more engaging assessments than just multiple choice questions and peer graded things that Coursera gives us. And so I have been excited about this program and just amazed at the leadership of this program and my colleagues, and the fact that we even did it, to me, is almost a miracle, but it's gone surprisingly well. So thanks, Amy and Qiaozhu and all the leadership and all the staff and all the other faculty for just making this happen. I did my small part, and I'm proud to be part of it.
Thank you, Chuck. So let me tell you a little bit about how we're going to spend the next hour or so together. We have an opportunity to talk to 3 esteemed faculty from the Mads program and ask them any and all questions that you have about the Mads degree. So that would include things like, what's it like to be in Mads classes? How do the faculty approach teaching? What is the objective that our program is trying to meet in so much as how we prepare data scientists for the real world? So any and all questions are on the table, and I will go ahead and serve those questions up to our esteemed faculty. I should add that although this webinar is not admissions focused, certainly if you have admissions questions, you are welcome to ask them. And my assumption is that we will likely get to at least a handful of admissions questions in addition to the great questions that we ask our faculty today. In an instance where we don't get to your question, or if your question is super specific to you, for example, I recommend that you email us at umsi.mads, M-A-D-S, at umich.edu. We are more than welcome to answer any and all admissions questions or personal questions about your trajectory as a MADS applicant to MADS students over email. So I'm going to go ahead and get us started by talking a little bit to each of the faculty about how they approach teaching at MADS. So Chuck, I'm going to start with you. Can you tell us a little bit about how you approach teaching in MADS and the content of your MADS courses? And in particular, I'm interested in understanding how much they are similar to or dissimilar to the work that you do in your massive online open courses.
So that's a great question. And first, I'm going to say that not all MADS courses are alike. And I think part of any education is the diversity of the faculty members that you interact with and the diversity of their approaches to teaching. And so you have all kinds of different classes. My two classes, 511 and 611, are Postgres database and Elasticsearch is what I cover. And as I see how the curriculum fits together, I'm kind of a service to the curriculum, right? I'm not teaching deep learning or data mining or data lakes or whatever, but you're probably going to touch structured query language in all of those things. And the more you know about structured query languages, the better you're going to be in all the rest of the classes and in the real world when you get there. And so I approach these classes as skill-based classes, not project-based classes, not writing-based classes. All those are important, but a skill-based class really supports other classes. And so I focus in 511 and 611 on teaching you as much skill as I can, as quickly as we can, and so that you've just got something, right? It's like practice for the real thing. And the real thing is courses like the capstone courses, et cetera, where you're going to use all this. And so because of that, I design courses in a way that's very similar to the way that I design MOOCs, in that I want them to be auto-graded whenever possible. I use peer grading once in a while when I can't auto-grade something. I want my courses to be something that you can work through efficiently. I'm not trying to sort of throw challenges in front of you. I'm just saying, I want you to learn this, and this, and get through it and prove to me that you know it. And we're going to move on because it's just one part of a bigger degree. And the degree is what's important, not an individual class. So my classes are set up to scale. They're set up so that if we have 40 students in it or 400 students, it's not that much harder. And that sounds like a MOOC, but in some ways it's not a MOOC. So the big difference between how I approach a MOOC, and I've actually turned 511 and 611 into a MOOC called Postgres for Everybody. And it just launched a week and a half ago. And it's the same material, almost the same material, but the experience turns out to be completely different. It's like you can take a textbook and teach many different kinds of classes from that textbook. And so the content of my course, I can teach lots of different courses. What you're going to find when you join MADS is it moves along with pace. We do not sit around and try and go, well, I got to go on vacation. It is a fast moving curriculum with a series of 4 credit classes, right? And so you're in, you're out, and you're on to the next thing. And that's really what residential and this kind of MADS online is we find a way to teach you material in 18 months to 24 months that literally, if you tried to do it on your own with YouTube, would be the rest of your life, right? And so we're trying to concentrate your learning. And so you could do a lot of this with MOOCs and YouTube and books and who knows what, but again, where you're going to be at the end of MADS is ready to go. And so that's how my class is different than my MOOCs. My MOOCs are like, I want you to take your time. You're enjoying yourself. I'm enjoying myself. But in the MOOCs, it's like time to go. And because of that, we need to support you. So we have teaching assistants. And so when you get stuck, we do not want you to be stuck for a long time, because if you get stuck, then you waste a lot of time. And we can't afford you to fail a four-week class, because now what do? We got to wait. And so we got to help you. We put pressure on you, but we also are there to help you on Slack, in discussion, et cetera, et cetera. So that's the primary answer to the question, Amy, and I'll send it back to you.
Thanks so much, Chuck. You did such a great job of talking about some of the signature pieces of our program, including our 4-week 1-credit courses, in addition to all of the great support that we provide MADS students in the courses, knowing that the pace is very quick. Now, at the same time that we are offering these great application courses or courses that are relevant to how people practice data science in the field, we're also giving students this great opportunity to participate in project-based courses. Elle, could you talk a little bit about your work in some of our project-based courses?
Yeah, so right now I'm working on, I've taught, this is my second time around teaching one of the first milestones. And what we have is a structure where there's kind of, you take some skill-based classes, then you take a milestone, which is a project-based course. Then you take some more skill-based classes, you do another milestone, you do a little more, you do some polishing, maybe you dive deep on a particular interest like NLP or data science, for social applications or ed tech. And then at the end, we have this project, this capstone. And that's what we're running for the first time. And that's my class this summer. And the idea is basically that, by the time you've taken all these skill-based classes and gotten a lot of perspectives on data science from a lot of different practicing data scientists, you probably kind of have a sense for what your interests are, what your niche is, and what you really want to dive deep on. So my goal is to give you, 2 to 3 months of protected time to really dive deep and kind of make like a portfolio piece that you can use to prove yourself and kind of announce yourself to the data science world. So we're running it for the first time. So it is itself a startup, seeing how this goes. But, the idea is I watch a lot of TV shows that are like the Great British Bake Off or Project Runway. And the idea is that I'm just going to try to set up a workroom for you. And I want you to show me what you can make with some of these tools. So some people are going to go deeper into, computer vision, natural language processing. Other people might pursue data journalism, and it's going to be producing something in the end that you can show to a broader audience of, professionals. And the idea there is that I'm trying to, set you up and put some guardrails in and make sure that, you're roughly on track, you're getting there, but I'm also going to stand back a little bit. And the data science team at this final capstone stage becomes more like you have consultants. Like we're going to meet with you and we're going to check in, but we're more like consultants and you're the boss. You get to decide what goes in, at the end. And so it's just a really different experience. And I'm, trying to emulate, some of the challenges you get when you just have to, find some data in the real world that you're passionate about. And then you discover, oh, wait, this data set, maybe it doesn't work as well as I thought, or the signal I thought was going to be here isn't here. What do I do? Or, oh, I think we're a little bit behind and debugging is taking longer. I'm trying to force you to, experience those difficulties and, learn how to overcome them. And we're giving you a kind of protected space to do that. And so, the hope is that because of we're really in this class format, because you've got the social support, because you've got instructors like me, that you are going to finish this. Whereas if you just try this at home on your own, it can get kind of discouraging. And sometimes those things go into your, okay, I'll figure out how to debug this later kind of bin. But we're going to get you all the way through, and we're going to help you get something that, announces you're coming out to the data science world.
I love that, Elle. And certainly because you have such great and rich professional experience, you know better than anyone the value of doing this kind of project work as it prepares you for employment in the data science world, as well as giving you tangible portfolio pieces that you can show potential employers or your current employer if you're looking to be promoted into a senior data science position. Qiaozhu, so you, of course, teach in the MADS curriculum in addition to all of the great leadership that you've demonstrated as a program director. And certainly you and I both know that we get a lot of questions about things like our rigor in the machine learning curriculum, deep learning, NLP, right? Some of the kind of hot topics in data science. Can you talk a little bit about how we're approaching those courses and how you're teaching on those topics?
Absolutely. Well, I mean, this is a hard question. You can see that Elle has said a lot of great things about, the exit, right? We want you to become, the data scientist in your field, and you can actually demonstrate the mastery of the skills using portfolio projects like this with great real value. But we expect that students coming into this program are not necessarily like, computer scientists or people who have lots of experience with data, right? You may be the domain expert that education, sports, right? Healthcare, and you wanted to actually learn the whole thing. So rigor, is one top, priority of our design of curriculum, right? So we are very, proud to provide this end-to-end data science pipeline in our curriculum. We start with how to formulate problems as the data science problem. What are the questions that can be answered through data science in different domains, right? Articulating the ethics issues of these problems, how to collect data from these domains, how to put this data into different formats so that you can actually use Chuck's, structured database to actually handle them. And then how to get into, large-scale data processing, data analytics things like, data mining, for one example, machine learning, and we actually cover a full spectrum of machine learning, starting from supervised learning, unsupervised learning, deep learning, machine learning pipelines. Soon there will be reinforcement learning, and then we're talking about yet another machine learning courses very soon. And then after that, we will teach students how to apply these data science techniques in, either dealing with more specific, more complex data types. For instance, network analytics and natural language processing, or how to actually deal with the connection between human and data science, like through experimental design analysis, also known as A/B tests in industry. Right, how to draw causal, conclusions, how to communicate data science results to your stakeholders. And then we apply the data science techniques into different domains. We have a set of data science application courses. They serve for two different, perspectives. One, they help you to understand, what's going on in each domain, right? Even if I'm not a data scientist in education, what are the problems that people care about in online education? What problem people care about in sports analytics, in healthcare? And also, we try to give you the opportunity to shape your capstone project in such a domain. And then after this whole pipeline of technical courses, you get into else court to design the capstone project and put that into your portfolio. Personally, I teach a few courses in this whole pipeline. I teach data mining 1, data mining 2, and am busy preparing the application course called Search and Recommender Systems. So I think the courses I teach sort of reflects this whole pipeline, but in a smaller scale, right? So in these courses, students consider them as quite technical, but we try to blend, theoretical models, algorithms with, practical data and, real problems you care about. In data mining 1, we talk about how to deal with item set data, where we use emojis that you use every day as an example. And when we talk about time series analysis in data mining 2, we help you build models to forecast COVID-19 trends, right? And then in the new Search and Recommender System courses, we tell you about secrets behind Google, behind Microsoft, in Facebook's face ranking, and Amazon's recommender systems, and so forth. So you can see that the whole pipeline of courses are backed up by the expertise of UMSI's top-class, world-class faculty in data science. And we hope that you will enjoy the whole journey.
Thank you, Qiaozhu. So we have a question where someone is asking us to compare a bit against other programs. So for example, within the School of Information, we have several prestigious residential programs. And then of course, there are also other data science programs kind of in the wider landscape. So can you talk a little bit about what is different about MADS, for example, versus our residential MSI degree, or what is different about MADS as it compares to, for example, other data science degrees?
Absolutely. Before talking about difference, I wanted to talk about commonness between the two programs. Both programs are taught by, the co-faculty members in UMSI. So you are likely to see, the same faces in the residential program and also in the online degree, right? And the difference is really about the innovation of online education, right? Through the online program, that there are lots of things that we can deliver thanks to the availability of, online education tools, like all these expertise we learned from the MOOC world, everything that Chuck has said. So in the MSI program, most students come in with 0 programming skills. So you can see that they actually take 2 years to finish the program. And like all the other residential programs, in the residential program, every course is 3 credit long, so you spend 1 semester learning these courses. Right. But in the math world, first of all, we, value rigor. And besides rigor, there's flexibility. So students can actually take 1 year, 2 years, 3 years to finish the program, given your own pace. And to that regard, we design the courses differently. So every course is just 1 credit, 1 month course. So you can actually play with your blocks, with your, Lego, and then, try to find the best schedule that fits your need the best. So I'd say that the math program is really an innovative, academic program that we're very excited about. And our goal is to build the best data science program in the world.
Absolutely. Chuck, can you build a little bit on what Qiaozhu just offered by talking a little bit more about our 1 credit, 1 month courses? So in other words, you teach in both our residential programs and in the maths degree. As Qiaozhu indicated, that's one of the things we really value about our program, is that we have the same core UMSI faculty, Qiaozhu as well, Elle as well, who teach in both residential programs and online programs. But can you talk a little bit about why we adopted this approach and some of the benefits of this approach?
Well, I would also point out that you'd see the same faces if you were an undergraduate, right? And so we just have faculty, and faculty sort of wander around and do their thing, and we don't have faculty that we hire to do special things, right? And we just have a faculty, and that faculty teaches our courses, and I think that's kind of different. I would say the 4-week format, to be honest, I think it came through the innovation of the experience of our MOOCs, because when we started in 2012, I took a course that took 15 weeks and turned it into 20 weeks. And if you looked, people would drop out. And part of it is if you're distance and online and you haven't moved to Ann Arbor, you still have a life, and that life can come calling at any given time. And through a lot of experiments and data, et cetera, we realized that 4 to 5 weeks was the sweet spot, right? And it was the idea that you're going to lose. There's each week you go, there is a probability that something will cause you to maybe detach from that class in that week. And of course, you talked about the flexibility, right? And so, you don't have to say, I'm going to do it in 3 years. You can say, I'm going to do it in 1 year. But then all of a sudden something happens, so now you're going to do it in 18 months, right? And so for me, the primary value of the 4-week unit is if you somehow get interrupted or you have to adjust, we can more easily wrap around that and meet your needs. If we are doing a series of 15-week things and something goes wrong, as it does in our residential programs, it's often 6 months to a year before you recover from that. And this way you can, heaven forbid, get COVID, right? And you need to take 3 weeks off, and you should take 3 weeks off. And we want you to take 3 weeks off. We are very sensitive to things that happen in your life, not even as bad as COVID. Maybe you have another child or something. And so for me, the 4 weeks it's a pretty good chance that you can start and finish that 4-week thing. And now you've got a credit, as compared to a 3-credit thing that you can start and get halfway through. And if it doesn't work out or something happens in your life, well, then you got nothing. And so you can't keep your progress. That's the good news of the 1 credit. When I went to undergrad, we did three terms rather than 2 semesters. And what I liked about that was you get a fresh start, right? If you're in the middle of a 3-credit, 15-week class and it's a bit of a slog, I don't know, maybe you don't like the class, or maybe the class isn't speaking to you. Well, it's going to be over in 3 weeks, and you're going to get a new one. You're going to need to see a new face and a new class. And so I think that's what's amazing. I mean, it does mean that you can't let things slide. We got to get you through it and get you through it in a hurry. And so I think it's really, we've learned that 4 to 5 weeks is a thing that people at a distance who are living a life can focus on something, and then if they can construct these 4 to 5 week pieces to an overall curriculum. I would say that's probably the biggest thing about the 1 credit 4 week format.
Thank you, Chuck. I really appreciate the thoroughness of your insights on why we picked that model and some of the benefits that it gives us and some of the benefits that it gives our students in so much as how they flexibly approach the trajectory of their degree. At the same time, we also know that a couple of our project-based courses do give students a little more time. So they are 8-week courses. And so it gives students an opportunity to delve a little bit deeper. And Elle, as you can imagine, we're getting some great questions about the project-based courses generally, but in particular the capstone. So could you speak a little bit to a couple of things? One is the kinds of tools that or services or systems or infrastructure. For example, cloud computing resources like AWS has come up. Can you talk a little bit about how students may have access to or use those resources in their capstone? And then can you also talk a little bit about what the output of the capstone is? So at the end of the experience, what is a student kind of left with, and where might they take that asset?
Yeah, so great question about, the resources. So, we're increasingly seeing a convergence of, some data science jobs are kind of synonymous with data engineer, and there the cloud compute is, it's kind of important. And so, even though that's not something that all students want to get into, we're trying really hard to make it available that if you're interested in cloud compute, that you will be able to use that. So we're working on a partnership right now with AWS so that we can, ensure some number of credits are available to every team this summer as part of the capstone. So there will be some availability there. And, basically the idea being, just we're going to give you a set number of credits. Feel free to use it. If you need more, you can appeal to the course team. And, so that way you could use GPUs, you could use, if you just want it for the web infrastructure, perhaps you just need an S3 bucket. So we're working on that. We also have, what was I going to say? We're not this summer, but we're starting up, we believe in the fall, a cloud computing class so that, right now it's kind of, if you come into the capstone and you want to use it, hopefully, you know how to use cloud compute a bit. And we actually have quite a lot of students that, just by their own interest, they've really gotten into it, which is very cool. A cool thing about having students in the cohort that are naturally interested in cloud compute is they kind of can teach everybody a bit, and just being around people that are interested in this, that are talking about it, that are exploring it, like that's a huge help. Like I would even say just being in the Slack channel with people who are talking about these things is a way to learn. And so, we're going to have a class so that everybody who wants to can learn how to start using cloud compute, because it does seem to be a pretty foundational skill for a lot of data science jobs. And so, we're working on how can we make those best available. So something we'll be looking forward to after this capstone is feedback from the students of, okay, how did getting AWS credits work for you? Is this the system you want? So we're going to be kind of continuously revising this as we learn, from how students actually work with it. But yeah, there's an abundance of cheap and free compute out there, and I would love to get you on it. It's really life-changing for sure. It was for me when I learned I could have a computer anytime, anywhere. And what else? So for the project itself, so for the capstone, on this iteration, the way that we're starting out is we're going to have team projects and over, 12 weeks total. So a couple weeks before where people can group up, work together and decide what they want to do, make a proposal. I'll just say, okay, yes, that's a reasonable project. And then they'll have, 8 weeks of crunch time where they're going to work together. And the things that they're going to turn in are a GitHub repository full of their code. So I want working code, reasonable documentation. You're going to write a blog about it. And so a blog is something kind of for the general community of data scientists. So even though you might dig really deep into something about NLP, I want you to be able to explain this, to a room full of, people who work in data science, but maybe are not exactly experts in that domain. So you're going to write a blog. Some groups will also kind of write a blog that's also sort of a scientific paper, because we have some people that are interested in submitting to conferences and such. So we can accommodate that as well. So you're going to be writing up something that's ready to share, in a way that you could, if you choose, you could put this on your LinkedIn or on your personal blog or on a Medium blog, because of, I've actually gotten a lot of my jobs through just writing about what I've done and sharing it in the data science, internet community. So that's, a great way to get yourself out there. And in addition, I'm going to be asking for a video overview of it. So another really good tool is YouTube. And so I'd like students to learn how to make a high-level video explaining what they've done, and they could just embed that on their blog, or they don't have to show it to anybody if they don't want to, but video really works for explaining, can you give us an explainer about what you did and why this is really cool. So those are the deliverables that we're looking for. And of course, you could turn in more than that. Some groups, they make like a web page, they can have like a dashboard. Some people, I've left open, if you want to work on an open source data science library, that's cool too. Then I want to see, you turn in your code repository for that. So, those, I have a bare minimum of what I want, but alternate formats, just show me what it is that you want to make, and that might well work.
Thank you so much, Elle. So we've talked a lot about the end of the MADS experience, and what I so appreciate about everything that Elle's saying is that we're really attuning again to what it means to well prepare our students for practicing data science in all of the fields where we're seeing such great demand for well-trained data scientists. At the same time, one of the things that makes our program unique is that we're not necessarily preferencing a technical background to get admission into our program. So in other words, we're saying we have an approach to data science that enables folks that have technical backgrounds. And in fact, we have those folks, engineers, for example, and others. But we also have a program that can accept and invite people to join us from non-technical backgrounds. So for example, we have lawyers that are in our programs, or doctors or others who come from very different career fields. Qiaozhu, can you talk a little bit about how we support students, regardless of their background, technical or not, to set them up for success in what we're trying to achieve in the MADS degree?
Absolutely. Amy, part of this is related to the admission, right? We have, a carefully selected, set of preparations that we recommend to the students to get into the program. And once you're admitted to MADS, you will still receive lots of support from the entire program, right? First of all, you can actually see that the excellent staff like Amy and like some other names you will see later will give you lots of advices on how to actually pipe your courses, right? So that you can actually get the best experience of getting bit to bit from what's actually required. And then, we create Slack channels for every course. So you will be hanging out with a large cohort of students who are actually in the same course. And believe me that sometimes you will receive lots of help from your peers, way more than what you will receive from the textbooks or from the instructional team. Of course, the instructional team will work very closely with you, and we recommend additional resources for you. We recommend, lots of, additional practice for you if you're interested, and different personalized paths for you to become successful. For certain students, if you think that you want to actually take a slower pace to actually prepare to build up your programming skills, we also have the so-called pre-MADS model, or slow cook model that actually Chuck and another fellow faculty, Paul Resnick, have innovated. I will leave that to Chuck later to talk about that. But one thing that we observe from MADS students is that we are providing lots of flexibility in terms of the the curriculum, and we hope that the students should actually enjoy this flexibility, right? So we would sometimes recommend you not speed up, but to slow down. And you slow down in order to actually speed up. So Chuck, sorry that I steal your memo, right? So take the time to actually go over what you have learned, to actually better prepare for the downstream courses, right? And take 1 month or 2 months off is definitely worth it. And sometimes it will actually help you speed up dramatically in the downstream courses. So maybe Chuck want to talk about his innovative program?
Sure, I have to unmute myself first. So I think the first thing to say is to clarify a bit of what Amy said, and that is we have tailored this program so you don't need a bachelor's degree in computer science, you don't need a bachelor's degree in math, you don't need a physics degree, you don't need whatever. And so literally you could be a practicing attorney and decide you're going to take this program. That doesn't mean that this program doesn't require you to know how to program, that somehow you can sort of come in and write a few essays and wander out, right? And so the difference is that we will give you the needed preparation, right? I mean, we're not going to say, well, you needed to take these 2 undergraduate degrees before you came. There are some skills we expect you to have, programming and statistics in particular, and there are ways to get those. And I think a mistake that students make is they think, oh, well, and it works this way in our on-campus program, but this is why it's a 2-year program. We'll catch you up on some of that stuff in a 2-year program, but we did not put time in this 1-year program for you to catch up. And so you want to catch up before you really engage. And so you can't just walk into, there's a few classes that don't require it, but you do want to have confident skills. And it's a little different than being a computer scientist. It's not like you need to be a programming wizard and understand alpha beta pruning and hash maps and stuff like that. But you do want to be a confident programmer. So you're like, you know what a loop is, and you really know what a loop is. And so there's a big difference between being a programmer, able to write code to accomplish things and not be scared of that code, and being a computer scientist where you're like, how would you build the Python interpreter? That's a computer science thing. That's not what we're dealing with here. But you do want to have strength and confidence in your ability to write code. In 4 weeks, we're not going to all teach you Python and then teach you how to do machine learning with Python. We're not going to do that in 4 weeks. And so the slow cook, that probably is not our official term for it, but the slow cook idea is that not just, you need to have these skills, and we want to find ways to better help you get those skills. And the simplest way is to just take a bunch of MOOCs in the summer before you apply, or have taken them before, and get confident. And don't worry so much about how much you take, but being strong at the end of your knowledge. It doesn't do you any good if you go and spend a year and take a whole bunch of MOOCs and then forget all of it, right? It does you no good. It would be better if you took a smaller amount of information and absolutely mastered it and absolutely understood it, because we will, use Python, and it's not like our first programming assignment is write 5,000 lines of code, but we will say write 20 lines of code, and we will kind of expect that you will know how to do that once we get into some of the applied classes, like even my 611. I'm like, write 20 lines of Python. I don't expect I'm going to have to teach you Python. And so we've been experimenting with different sort of on-ramps, right? We want the on-ramp to be gentle enough that if you take time and you follow where we're telling you to go, you'll make it no matter what your background is. And you don't need 4 years of preparation. You might need 3 to 6 months of preparation. And we focus that preparation on competency, on skills, and not teaching you more than you actually need. And that's one of the problems of taking a whole computer science degree. You would learn 10%, 5% of what you might know in a computer science degree is useful here. And 95% is computer science. And so what we've tried to do is give you a gentle on-ramp. At times we have, and Amy knows what our current status of sort of conditionally admitting folks, and helped you take your MOOCs. That's what we did in the fall, as Paul Resnick and I tried to help people say, okay, you didn't take your MOOCs, you didn't take your prerequisite, you didn't have the skills. We'll kind of work with you in the fall, and you better avoid these classes until you get through this stuff. And so we're coming up with as many ways as we can to make your on-ramp work for you, right? We want to take everybody. We're not gonna We're not going to switch to filtering you and say you have to have a math and computer science degree to come in, because then we would cut out all the kinds of wonderful people with all these wonderful perspectives. And so, but we understand we've got to help you through that. Whatever the on-ramp is that we invent, we're going to help you through that on-ramp, and we're going to keep working. You know, that thing we did in the fall was an experiment, right? It's not like we're going to do it forever. We might change it. We're just working on finding ways for you to get the prerequisite skills you need in a way that works for you. And so I know in our committee, we have long conversations. Elle's on the committee, Qiaozhu's on the committee. We talk long and hard about how to get you to the point where your skills are ready to sort of do really well in all the classes without over teaching you or wasting your time.
Thank you so much, Chuck, for adding such great nuance and depth to how we support students, regardless of whether they come to us with lots of programming experience or little, as well as some of what our expectations are for what it means to program well in a degree like ours. So we've been talking a lot about flexibility, for example, but Qiaozhu, at the same time, we are not sacrificing rigor. So can you speak a little bit to the difference between a 1-credit maths course and a 3-credit traditional residential course, and how we're managing that 1-credit model to still ensure a high amount of rigor in all of our courses?
Well, thanks, Amy. This is a great question, right? I have designed multiple courses, so I, can actually experience that we made a nice decision to actually create 1-credit 1-month courses. So, one common understanding of, creating 1-credit courses is like you break a residential class into 3 classes, right? We're not doing that. Right. In fact, all the 1-credit 1-month courses are to some extent brand new because we actually we find the synergy in, all the existing data science curriculum. And then we identify those logical modules that could actually, help us, identify this and deliver this end-to-end data science training. And those are essential. Those are dependent on each other. And those are not like overlapping crazily, in a way. So if you look at these courses, I'd say that each of them is a very well designed, is a specially designed module, right? That will teach you, the unit that is self-constant, but also logically connected to all the other modules. Right. If you look at, I hate to say this, but sometimes when you teach the course for 10 years, you have lots of things that are already, embedded in the courses that you wanted to change them. You never had the opportunity to actually change them. And then the next morning, you find that your faculty peers are doing the same thing. So you look at 2 residential courses and you find that, oh, how come that they have such large overlap, right? But in maths, because every course is, getting through the formal process of being proposed, being reviewed by the faculty committee, and then being designed by the professional, design team, and then delivered by the team of instructors. So we make sure that all the courses are, contributing to the curriculum and making unique contribution to the curriculum. Right, so we try to avoid lots of overlaps. We try to, blend classical, theories with the, state-of-the-art models. So with that said, we really think that this online program is the innovative, residential class experience instead of just, breaking the 3-credit course into 3 1-credit courses.
Thank you, Qiaozhu. So as our students are navigating this novel model, as you can imagine, we do a lot of evaluation and assessment on what's going well, what's not, both in so much as how our classes function, the cohesiveness across the curriculum, and we're also looking at our students themselves. So Elle, can you talk a little bit about what you see as some of the kind of positive attributes or some of the things that you think, yeah, math students do this really well, or this is what makes kind of a great math student, as well as maybe a little bit about what you see as some of our students' growth areas, things that you would say, oh, we might want to address that a little bit more in the curriculum, or we might want to see students be a little bit better prepared in this area.
Yeah. So I I really like our students. They're really cool. You know, I really, something I love about data science is that it does attract people from a lot of very non-traditional backgrounds. And as long as you can get the basics down, what you bring to it in addition makes you really cool. So, you know, some of my favorite students, you know, can I have favorites? I don't know. I really love some students, you know, that they show up every office hour. So even though it's remote, like I have office hours and there's like a club of people that come every week. And I think it's just to have that camaraderie, which is really cool for, you know, an online program. So, you know, you don't have to feel like a stranger, and you really can meet with people regularly, including your teachers. So I find, you know, that they're really ambitious. It's a blessing and a curse. I find that a lot of the students already have, you know, quite strong identities professionally. Some of them are, you know, people that they've been working for several years, and getting a master's degree is going to help them advance in their company or switch to, you know, a new higher paid job. You know, and that's something I love about data science is, you know, getting a job in data science is life-changing because of, you know, for someone like me, it helped me pay off all my student loans really quickly. And it got to be like, it is so cool. So it's like, it's truly a job that pays well and is definitely never boring. So I want it for a lot of people. And our students sense that, they know it, they have that hunger for it. And, you know, they're really ambitious. The curse there is that sometimes the projects are so ambitious. And I find a lot of times I'm telling them like, you know, it's okay to be simple and right, you know, like just do something small and nail all of the details. Like I would love to see that, you know, or you don't have to show me every single plot in the world. A really great data scientist has discernment. You don't, you know, you know, when there's just one figure that's going to tell it right. And if it is a simple figure, if it is a bar chart, then that is the right chart. So I sometimes have to talk people down off of a ledge. If you don't have to be fancy, you just have to be honest, transparent, and good, you know? So I'm trying to imbue that sense of, you know, confidence, you know, in what you do, being, you know, when do you know when to stop, basically, or when do you know how to pick what's most important? You know, one thing that because I'm a math major, as my undergraduate, I think that really learning how something like linear regression works, like, I mean, really learning that kind of changes the way you think about everything else. And so I'm still, you know, pressing and working on getting into the curriculum. Like, man, I would love to spend 4 weeks going down, like, what is a loss function really? What does it mean to optimize? You know, what are we fitting? Things like that. I just want to make sure students really get that, because I think it's possible still to finish a data science program. And this is true of most data science programs. I think without, you know, understanding that at a deep level. And if you just understand kind of the fundamentals there, then that carries over to every single deep learning, you know, or even fancier kind of, you know, approaches. So I just want to make sure that, you know, at the end of the day, people really know a couple things about statistics and, you know, and some of the math basics, but those like 5 things they really understand. So that's something that I'm, you know, my next few years as part of the program, I hope to make my mark on the program in that way.
I love that. That's the first time I've heard it, and I'm very excited about it. So the math question, as you can imagine, comes up often. And Qiaozhu, can you speak a little bit to how we've integrated math into the curriculum?
Yeah, absolutely. So sometimes we receive questions from students that, you know, how many math courses do you have? How many stats courses do you have? And this is the question that's, you know, that's never going to be answered right, because, you know, we're not like, you know, creating a program that we spend the first half of the courses just about math, and then the second set of courses just about data. We don't do that. We actually blend, you know, math and stats into every aspects of the courses. So into the program that we do have one course, and we're now thinking about, you know, extending that into 2 about math methods. So that's going to be talking about the very basic math concepts to refresh your memory about, you know, statistics, about linear algebra, about, you know, matrix factorizations, about like the simple optimization, you know, techniques that Elle is just talking about. But then instead of just going over all those concepts, we will show you how these concepts will be used in downstream courses, right? And how you can actually, compute those using program, for instance, using, LangPy or other, Python packages. So instead of spending one semester talking about let's see non-convex optimization, we will go into the downstream courses and then refer back to those math concepts when you're actually using it, and then at that time you should understand that, oh, why this method will be used here. It was foreshadowed before, and now I understand that why this is useful. So you can actually find, a large proportion of math methods, stats methods covered in exploratory data analysis, machine learning, data mining, network analytics, causal inference. Of course, you can actually find, causal inference is actually the core course offered in stats departments. And also you will find them useful in, let's say, experimental design analysis, and also like natural language processing, reinforcement learning, and so forth. So if you ask the question again, how many math courses there are in the program, I'd say that probably 2/3 of the courses are related, right? But if you ask me how many courses are purely about math, I'd say none of them.
And I
That's
probably
very well
think
put.
that's how it should be. I will note that the students actually have self-organized a math club where for the people that are really into, like, they want to read papers and they maybe want to go over the algebra together, they do it. But for a lot of the rest of us, math can be accomplished programmatically. And that's also the angle that I prefer to teach it from. It's also how I learned it best. You don't have to be an algebra whiz to really, be using math well as a data scientist.
Thank you, Qiaozhu, and thank you, Al. And Al, you also mentioned something that I think is such a bright spot for our program, and that is the number of self-initiated communities within the larger maths community. And so we have students, for example, that have a deep passion and commitment to data ethics. We have folks that really love math. We have individuals who are committed to reading books on data science and then sharing their opinions of those books in a book club. And then, of course, we have the infamous pizza channel. So for those folks that love pizza and want to share that across the program with others that also enjoy pizza, we have a space for that too. So Qiaozhu, as folks are preparing for the degree, typically we indicate to them to take at least Python 3 programming, which is a series of MOOCs that you can also get a certificate for that you can use in your application to the maths degree. Certainly, if you're brand new to Python, starting with Chuck's courses and then moving to Py 3 afterwards. Prepare for.
Yes, Amy, this is accurate. So as you see that we're trying hard to find the appropriate materials for students to prepare for their entrance into maths, right? Sometimes they exist, like, the Python for Everybody, wonderful, Python programming specification. And then there's the Python 3 specialization. So statistics in Python did not exist when we started this program, right? Now it's there. So, we make this recommendation. We hope that our knowledge is going to be updated whenever there's something nicer and more suitable coming up in the field. So our goal is to keep this program as innovative as possible. We want it to, always move ahead, right? If the faculty decide that, okay, we need something more special, right? We think that providing MOOCs specialization about optimization, about loss functions, or about A/B tests, they are very useful for your preparation. And then I'm sure that we will propose it and we will do it.
Absolutely. What I love about what you just said is that not only are we thinking deeply about preparation, but we're also um, we're iterating, right? And MADS is committed to maintaining its nobility, but in intentional and strategic ways, and being at kind of the cutting edge of what we know to be teaching data science, and again, kind of how to best prepare folks for the data science field or fields. So we've just got about a few minutes left. There are several admissions questions that were asked in the chat that we didn't get to. So I will encourage everyone again to email umsi.mads, MADS at umich.edu with your specific admissions questions. Those would include questions on admissions dates and assessment deadlines, in addition to questions about scholarships, for example, or other aspects of your application. Please do send all of your questions there. We are more than happy to answer any and all questions. So as we start to wrap up, we've talked so deeply and richly over this last hour about everything MADS and all of the great reasons that all of the folks that are joining us today should come and be in the MADS program. Could each of you just very briefly, and I'm going to start with Chuck, just say a couple of concluding thoughts as we end our time today?
Well, I think it's a magical thing. A good education is when a diverse and excited faculty kind of collide with a diverse and excited student population, and amazing things happen. And I think that what's cool about MADS is that because of the way we've built the curriculum, you get a bunch of faculty and they give you their expertise. And like Qiaozhu said, there in our other curriculum, we find lots of overlap, and we find that this faculty kind of teach the same thing. But because each of us is teaching kind of a concentrated version of the essence of what our skill is, you kind of know more than we do when you're all done, because you've like taken all of our best, right? I've given you my best 4 weeks. Now, Elle kind of is more like a graduate of the program, right? In that she knows a lot of stuff, and that's why she is where she is. But I'm blown away, honestly, at what our students are capable of doing. And I don't think I would be ready to succeed in this program. It's challenging and it's good. And the sum total of all the different things is an amazing set of skills.
Thank you so much. Qiaozhu?
Well, Chuck's always, very insightful. I would add that, data-driven decision-making or data science-driven science is the trend, right? I think we are lucky to be part of the trend, and we did some small things. MADS is extremely lucky for that. We have, excellent leadership and staff like Amy and her team. We're extremely lucky to have our first cohort of students. Believe me that we learned a lot from them, right? We think that these students are actually shaping MADS. Right, in a way, you got to look at the Slack channels and look at what are these very insightful questions they ask, feedback they provide. To do this, but we are humble. We wanted to actually build the best data science program in the world, but we cannot do that without you participating in the process.
Thank you so much. And Elle?
Yeah, so a lot of really good things have been said. I guess I will say, I think data science careers are fantastic. Like, it's a great place to be. It's one of the coolest places in the world. There's so much action. There's so much, places to have an impact. So many, basically every discipline and domain, is going to be engaging with this if they're not already. And so it's just a really cool thing to bring to your portfolio. The demand is huge. It's like I've said, it's life-changing too, to be able to get a data science salary. And so I like it in this way, that it gives people so much flexibility for growth over their career, so much opportunity. And it's a really cool place to be. And I would also say that, definitely came of age in data science as I was doing my PhD, and I taught myself so much from around the internet, and it was really inefficient. Like it worked, but it was so inefficient and it was so hard. And there would be all these things that would block me because I just couldn't figure out, well, how do I get around this bug, or what does this thing mean? And if I had just had somebody that I could show up and go to their office hours and they could say, get me unstuck, that could have saved me, like, honestly, probably a few years. And so I really think that, you know, there's a real benefit to, you know, a program is more than the sum of the curricula on paper. It's also the support that you get, the network you get. And I think that kind of instruction, you know, being able to go to somebody and them saying like, no, try thinking about it this way. And then it clicks, you know, that is really what's valuable about getting a degree. So that's my pitch for it. I think that I would have, if there had been programs like this at the time that I was coming up, that could have saved me a couple years probably.
Thank you, Elle. That was incredibly well said. So as I indicated before, if we did not get to your question, I apologize, but please do email us at umsi.mads@umich.edu. We will also host another webinar, details coming soon in this admission cycle. So if you'd like to join us in a future date, we will have that shortly, and it will give you another opportunity to ask all of these great questions of MADS faculty, staff, and sometimes even students. So thank you again for joining us today. We had a really wonderful time with all of you. I strongly encourage all of you, if you haven't already, to start those applications. And as always, go blue.